All right, today we're going to be talking about inverse functions, and the first thing we're going to review is what it means to be a one-to-one function. A function is said to be one-to-one if any two different inputs in the domain correspond to two different outputs in the range. So all that really means is not only are the x's not repeating, but also the y's aren't going to repeat. So here's an example. Is each function one-to-one? So first thing I'm going to look at is it a function? -2, -1, 0, 1, and +2. So none of the x's repeat, so I know it's a function. Now I want to know, is it a one-to-one function? If it's one-to-one, it means the y's also don't repeat. So 6, 3, 2, 5, and -6. So not only is this a function, but yes, it is one-to-one. Because it is a one-to-one function, it means its inverse will also be a function. So we'll look at B. -2, -1, 0, +1, and +2. So it's a function. Now to see if it's one-to-one, we're going to go check the y's. -5, +3, +2, -5, and +8. You'll notice that my y's, I have two values that are -5. So although it's a function, it is not one-to-one. Because it is not one-to-one, its inverse will not be a function. Another way to tell if something is one-to-one is to use what we call the horizontal line test. If every horizontal line intersects the graph of a function f in at most one point, then the function is said to be one-to-one. So look at A here. Example 2a. I know this is a function because it passes the vertical line test. Now, to see if it's one-to-one, I'm going to go see if it passes the horizontal line test. So if I were to draw a line going horizontally, it touches once, it touches once, it touches once, it touches once. So this is not only a function, but it's also a one-to-one function, which means its inverse will be a function. Letter B does pass the vertical line test, so it is a function. Now I want to know if it passes the horizontal line test. Well, if I were to draw a horizontal line through this graph, we'll notice that it touches once, twice, and 3 times. So it's a function, but it is not one-to-one. So since it's not one-to-one, its inverse will not be a function. So how do you find an inverse? Well, if you're going to find the inverse of ordered pairs, it's really simple. To find the inverse of a mapping or a set of points, all you do is flip the x's and the y's. So on my original set of points, we had -3, -2, 0, 2, and 4. And I put all of those in the domain part of the mapping. My y values are -2, 4, 3, -1, and 0. So to find the inverse, I simply flip the domain and the range. I flip the x's and the y's. So this is the notation we use for inverse. F to the -1. I'm going to take all of my range values and now I'll call them the domains. And the domains are going to map to the range. So we have -2, -3, 4, -1, 3, 0, -1, 2, and 0, 4. You simply just flip the x's and the y's when you're finding the inverse of a set of points. So on example 3 right here, find the inverse of the function. So to find the inverse, I'm going to go make my set. I'm going to go list my ordered pairs, and I'm going to flip them. So -2, -1, comma. I'm going to flip, and I get 4, 0. I'm going to flip, and I get 3, 6. I'm going to flip, and 2, 2 stays the same. And I'm going to flip, and I have 0, -4. And I'm going to close my set. The domain values of the inverse are the x's that I have listed here. So the domain is going to be -2, 4, 3, +2, and 0. For the range values, I'm going to have -1, 0, 6, 2, and -4. Now usually I order these from smallest to biggest, but for right now I just went and listed my x's for the domain and my ranges I listed the new y values after I flipped. Okay, you can also find the inverse of a graph by flipping the x's and the y's. For instance, x to the third plus 2 and the cube root of x minus 2. So x to the third plus 2 is this graph right here. Oops, right here. And the cube root of x minus 2 is the second graph right here. So all I have to do is take any x and any y on my original graph f of x and flip it. So right here it looks like I have a point at 0, 2. So if I were to go flip that, you'll notice I also have a point at 2, 0. Something else we'll notice is that inverses are symmetric, are reflection over the line y equals x. I could take anything from this graph and flip it over this line. See how it's a mirror image over this line? And it's going to reflect over the line y equals x. That's only if they are true inverses of each other. So here's an example. It says, draw the graph for the inverse function f. So here's my original function. I've got a point right here, here, and here. To graph the inverse, I'm simply going to go flip these points. So this point up here, 1, 2, 3, that's 0, 3. So I'm going to go graph 3, 0, 1, 2, 3. This point over here is 1, 2, 3, 4, 1, 2. So negative 4, 2. So I'm going to go graph 2, negative 4, 1, 2, 3, 4. And then this point over here, 1, 2, 3, 4, 5. That's negative 5, negative 1. So I'm going to go graph negative 1, 1, 2, 3, 4, 5. And I'm going to connect them. And you'll notice if I were to take this top half and flip it over this line, y equals x, it would lie right on top of itself. So to do a graph, once again, go find a couple points on the graph and flip the x's and the y's. Go graph them. Go sketch in your line y equals x and make sure that it appears to be a reflection across the line y equals x. Nice and easy. Number 5 is going to use what we learned yesterday. Another way to decide if two equations are inverses of each other if you don't have a graph is to go do the composites of your functions that we learned yesterday. So if I take f of g of x and I also go do g of f of x, and they both give me x, you have to do both. If they both give you x, then they're said to be inverses of each other. So when they ask you to verify or to not verify that anything, that two equations are inverses, you're going to go do f of g of x, and then you're going to go do g of f of x. So I'm going to do that right now. First, I'm going to go do f of g of x. So this is a review of what we did yesterday. So g of x equals, and just like yesterday, I'm going to go ahead and distribute negative 1/2 x plus 3/2. Negative 1/2 times x, negative 1/2 x. Negative 1/2 times negative 3 is positive 3 over 2. Now I'm going to take this equation and go plug it into my f. So f of negative 1/2 x plus 3/2. I have 3 minus 2 parentheses. And now I'm going to go plug this in. So I'm going to bring down my 3. I'm going to go distribute my negative 2. Negative 2 times negative 1/2 is a positive x. Negative 2 times positive 3 over 2 is a negative 3. 3 and negative 3 will cancel, and I'm left with x. So far, it looks like they might be inverses. Now I have to go the other way. So now I'm going to go do g of f of x and see what happens. So f of x equals 3 minus 2x. I'm going to take this answer and I'm going to plug it in right here. So g of 3 minus 2x equals, there's a negative 1/2 parentheses in place of x. I put 3 minus 2x, and then I'm going to bring down my minus 3. All of this went in place of that x. So before I start multiplying, I notice right away that I've got a 3 and a negative 3, so I can go ahead and get rid of those. So all I have inside now is a negative 2x, and I know that negative times a negative is a positive, and a half of 2 is 1. So yes, both the composites equal x. So yes, these are inverses. If either one of these had not been x's, then it would have not been an inverse. Another way to find an inverse, this is the last way we're going to go over today, is to flip the x and the y in the equation and then go solve for y. So here's an example. If I had the equation f of x equals 2x plus 3, we know from Algebra 1 that f of x just means y, so I went and rewrote the equation as y equals 2x plus 3. Then I'm going to switch the x's and y's so that it reads x equals 2y plus 3. And then I'm going to go solve my equation for y. So if I were going to solve this for y, I would minus 3 from both sides. So I'd have x minus 3 equals 2y. And then I would remember divide both sides by 2. So y would equal x minus 3 divided by 2, or a function inverse, remember this is your notation for inverse, is x minus 3 divided by 2. All right, so let's go practice one here. So the last part of the notes today, they want me to find the inverse of the equation f of x, and then they want me to graph both equations on this grid. All right, so I'm going to go solve for my inverse right here. So remember, I'm going to go rewrite this as y equals 2x minus 3. I'm going to go switch the x's and the y's, so x equals 2y minus 3. To get rid of a negative 3, I'm going to add 3. So x plus 3 equals 2y. And then I'm going to divide both sides by 2. So my inverse function equals x plus 3 divided by 2. So then the next thing they want me to do is they want me to graph both these equations, and they want me to put the line y equals x. So I'm going to do that first. So y equals x goes straight through the diagonal, 0, 0, 1, 1, 2, 2, 3, 3, 10, 10. So this is my line, y equals x. And then I need to go graph my original function, and I'm going to graph my inverse function. So my original function, I remember how to graph a line. This is my y-intercept, and this is my slope. So my y-intercept says I'm going to touch the graph, 1, 2, 3. I'm going to begin at negative 3. I'm going to go up 2, right 1, up 2, right 1. And I could do that all the way off the graph if I wanted. Okay, and then you're going to connect that with a line. This is my original function, and I'm going to label this one f of x. Now I'm going to go graph my inverse function. All I really have to do is take these 3 points and flip them. So this point right here was 0, negative 3, so I'm going to graph negative 3, 0. The second point right here was 1, negative 1, so I'm going to go graph negative 1, positive 1. This point right here was 1, 2, 1, so I'm going to go graph 1, 2. So here is my inverse. I'm going to label this one inverse. And you'll notice that if I were to take this part of the graph, this bottom piece, and fold it over this line, it lands on this piece. And if I were to go take this green piece and fold it over that line, it would land on top of the purple. So you graph your line, and then you take 3 points and you flip them, and that's it. Okay, let's go do one more. Let's go find the inverse of x squared plus 4. All right, so where it says f of x, I'm going to change this to a y. Now I'm going to go switch the x and y so that it says x equals y squared plus 4. I'm trying to get the y by itself, so I'm going to subtract 4. So x minus 4 equals y squared. I want to undo the square, so I have to square root. So the inverse function is plus or minus the square root of x minus 4. Okay? So I'm going to go graph x squared plus 4, and I'm going to remember to graph my line y equals x. So I'll do that one first. My line y equals x. I'm going to label that. I just need to go graph a couple of points right here. So I'll do it in purple. So I'm going to have a vertex at 0, 4, 1, 2, 3, 4. And I know this because I know my parent functions from the last test. 1, 1 got moved up to 1, 5. And negative 1, 1 is now at negative 1, 5. So here is my original. I'm going to take those same 3 points and I'm going to flip them. So this point up here is 0, 4. So I'm going to graph 4, 0. 1, 2, 3, 4. Right here I have 1, 5. So I'm going to graph 5, 1. And I have negative 1, 5. So I'm going to graph 5, negative 1. Okay. And that's my inverse function. This is my inverse. And this is my original. And that's it. So, your homework paper, again, it's going to be due on 2/12, next Monday. Let's look at a couple problems, not a lot, just to make sure you understand the directions. So, on 13 through 16, it says determine whether the function is 1 to 1. X's can't repeat, and the Y's can't repeat. So, let's do 13. I've got 2, negative 3, 4, and 1. So, all the X's are good. On the Y's, I've got 6 and 6. And then I have 0 and 0. So this is not 1 to 1. You're going to do the same thing for 14, 15, 16. On 17 through 22, it says the graph of the function f is given. Use the horizontal line test to determine whether f is 1 to 1. So I'll look at 17. If I were to draw a horizontal line going through this graph right here, it touches once, touches once, touches once. So this passes the horizontal line test. So this one is, yes, it's 1 to 1. On 27 through 30, it says find the inverse of each 1 to 1 function. State the domain and range of each inverse function. So on 27, first thing they want me to do is find the inverse, which means I'm going to flip everything around. So I'll write I and V. And I'm going to have 5, negative 3, 9, negative 2, 2, negative 1, 11, 0, and negative 5, 1. So to find the inverse, I simply flip them all. Now I'm going to go list my domain. My domain is just all the x values. So 5, 9, 2, 5, 9, 2, 11, and negative 5. My range values, I'm going to go list all the y's. Negative 3, negative 2, negative 1, 0, and 1. And that's it. You do the same thing for 28, 29, 30. On 32 through 36, draw the graph of the inverse function. For convenience, and as a hint, the graph of y equals x is also given. So on these problems, this is where you just flip the x and the y, and then you graph it. So they gave me the point 1, 2. I'm going to go graph 2, 1. They told me 0, 1. I'm going to graph 1, 0. They told me negative 1, 0. I'm going to graph 0, 1. Negative 2 flipped is negative 2, negative 2. I'm going to connect my points. And you'll notice that this purple, if I were to flip it over this line right here, y equals x, would lie right on top of the original. Remember, it's going to be a reflection over the line, y equals x. And you're going to do the same thing for 32, 35, and then 34, 35, and 36. On 37 through 46, they want me to verify the function f and g are inverses by doing f of g of x and g of f of x. So for each one of these problems, we're going to go do the composites. So on 37, I'm going to go do f of g of x. So I'm going to take the g function, and I'm going to distribute. So g of x equals 1/3 x minus 4/3. I'm going to take that equation right here and plug it into f. So f is going to equal 3 times 1/3 x minus 4/3, and then I have to bring down that plus 4. If I distribute, 3 times 1/3 is 1x. 3 times negative 4/3 is negative 4. And then I bring down my plus 4. Those cancel, and I'm left with x. So now I have to go the opposite way and see if it also equals x. G of f of x. So f of x equals, there's nothing to distribute, so I just rewrite it. And I'm going to take this 3x plus 4 and plug it in right here for this x. So g of 1/3 3x plus 4. All of this represents that 1x. I'm going to bring down my minus 4. I'm going to see that 4 minus 4 is going to cancel, and I'm left with 1/3 times 3x, which in fact is x. So you're going to do that for all of these. You're going to do the composite one on each side and see if they both equal x. If they both do, then check, we've verified it. If either one of them doesn't equal x, either A, we made a mistake, or B, they're not inverses. On 47 through 55, the directions say, find its inverse and check your answer. State the domain and range of f and the inverse. Graph f and the inverse, and y equals x on the same coordinate grid. So for 47, the first thing I'm going to go do is I'm going to go find the inverse. So we're going to go rewrite this as y equals 3x. The second step was to switch the x and y. X equals 3y. I'm going to go solve for y. This is 3 times y. So y equals x divided by 3. So my inverse function is x divided by 3. Okay, so I found my inverse. This is my original. I'm going to come over here and graph it. The first thing they want me to do is graph the line y equals x. So here's my y equals x line. Now I'm going to go graph the line y equals 3x. We know because it's a line y equals 3x. You can barely see the x and y axis in here. Draw those in. My x-axis. Here's my y-axis. Okay, so x and y. This line right here starts at 0, 0, so I'll do this one in purple. The slope is 3, so I'm going to go up 3. 1, 2, 3, right 1. And do it again. 1, 2, 3, right 1. Okay. I'm going to go draw that line. I'm going to label that one my original function. Now I'm going to take those 3 points that I just graphed and flip them. Well, 0, 0 flipped is still 0, 0. This point right here is 1, 3, so I'm going to go graph 3, 1. 1, 2, 3, 1. This point over here is 2, 6, so I'm going to go graph 6, 2. I'm going to draw that. And I'm going to label that my inverse by doing f to the negative 1. And you'll notice that if I were to take this purple part and flip it over this dashed line, it would land on top of the green as a reflection. And same thing right here, if I were to take this top purple part and flip it over the line y equals x, it would land on that green one. So that's what you're going to do for that section. I hope this helped. Let me know if you have any questions in class.